In statistical modeling, regression analysis is used to estimate the relationships between two or more variables, dependent variables and independent variables. Dependent variables, also known as criteria variable, is the main factor that we're trying to determine here, and independent variables are really your predictor variables, or the factors that might influence the dependent variable. This video uses multiple linear regression to predict number of investigation classifications expected to be recorded per suspect. So imagine this. This is Paul Oracle, and there are hundreds and thousands of tables and fields in Paul Oracle. So you're given this database and asked to do predictive analytics on it. This is heaps and heaps of data, and let's say you want to predict how many crime classifications is a suspect expected to be part of or allocated to in his or her lifespan. You have discovered dozens or perhaps even hundreds of factors that can possibly affect the number. But how do you really know which ones are really important and which ones actually make a difference? And how closely are each of these factors related to each other? And how certain can you really be about the predictions? And hence the reason we run multiple regression analysis. Multiple linear regression helps you understand how dependent variables change when one or more of the independent variables varies. It basically allows you to mathematically determine which of these variables really have an impact. This is the equation for multiple linear regression, wherein y is the predicted or the expected value of the dependent variable x1 through x infinity, or in our case x3. b0, or rather beta 0, is the value of y when all of the independent variables are equal to 0, and b1 through infinity, or rather beta 1 through beta 3 in our case, are the estimated regression coefficients, which basically represent a change in y relative to a 1 unit change in respective independent variable. However, before I delve into this, I'm going to talk about the data set which is used to achieve this equation. There were 4 distinct data sets that were created. First one was used to extract suspect iteration group, name, forename of the suspect, incident number, and home office classification short description. So in order to arrive at incident reference number and the suspect details, I connected crime table with the person table using the link table. From object type equals to crime and to object type equals to person with the link reason of suspect were used. However, it is important to note that the crime table does not contain the actual description of the offense classification. This detail resides in investigation classification table, which is a child of incident classification, which in turn is a child of crime. So these tables were connected using parent object ref, and the URN to arrive at the short title. Once I had this data set, then each suspect was identified by the iteration group ref, and a count was performed for the number of investigation classifications. This formed my dependent variable. Now let's look at the independent variables. The second dataset consists of number of references a suspect is associated with or a part of. So this basically covered any crime records, custody records, case references, stop and search, and the like. Basically, if a suspect is associated with these events in the capacity of either of the following: a suspect in a crime record, a detainee in a custody record, a defendant in a case record, a suspect of subject to search in a stop and search event, etc., then the count of all the records per suspect is performed. So this is my second data set. Now let's look at the third data set. This captured the average time to dispose of a crime. So let's say if a suspect is part of an investigation. Then, from the time that crime took place to the time that crime or the event was disposed of was calculated using the event on from date and disposed of date and time. An average was taken per suspect, since a suspect can be part of more than one crime. Finally, total number of victims associated with the suspect. All of these allude to a network analysis in various ways. So finally, now I've come back to Excel where all of this data was transported and cleansed. So in column C, I've got my iteration group ref, which is the identifier for individual suspects. In column D, I've got my dependent variable, and from columns E through G, I've got my independent variables. Many independent variables could be used. For the purposes of this demo, I have used these three. That's not to say that others aren't possible. So I ran a multiple linear regression on that dataset, and it resulted in this model and the summary output. So there's some key factors to note here. First one being multiple R. This is the correlation coefficient that measures the strength of a linear relationship between variables. So the higher this value is, the better it is, i.e. it shows the strength of the relationship. If this value is negative, then that means there is a negative relationship between dependent and independent variables. Adjusted R-square. This is the value that is used for multiple linear regression. In our case, it means 52% of our values fit the regression model. In other words, 52% of the dependent variables can be explained by the independent variables. Standard error. The lower this value is, the better off we are. Observations. This is simply the size of your sample, or n, or the number of records that are used in this model. There is a regression chart that's also created. Dependent variable is always plotted on the y-axis and independent variables are plotted on the x-axis. Trend lines have also been depicted here. Correlation between variable was also done simply to get an idea of whether there is multicollinearity present between independent variables. In our case, it wasn't really there, not very strongly, so that's fine. So in summary, I can say that there are two parts to this. The first part is to be able to create the dataset from raw poll database, and the second part is to run the analysis on that dataset. Thank you.